Okay, so far in this chapter, we have looked at positive exponents, we've looked at negative exponents, exponents of 0, and now we're going to look at rational exponents, exponents that are in fraction form. So in order to do this, we're going to go ahead and look at this first problem and just type it into our calculator and see what our calculator gives us. So we have 9 to the 1/2. So let's go ahead and put that into our calculator. 9 caret. And again, with fractions in this calculator, we do have to put those parentheses. So what is 9 to the 1/2? 3. Okay. Now let's go ahead and try 8 to the 1/3. 8 to the 1/3. 2. Okay. So how are 9 and 3 related? Well, I know the square root of 9 is 3. How are 8 and 2 related? Well, I know the cubed root of 8 is 2, which means 2 times 2 times 2 is 8. So 2 to the 3rd is 8. I know 3 squared is 9. Okay, so I'm going to write that down. I know 3 squared equals 9. I know 2 to the 3rd equals 8. So with that in mind, let's figure out what 25 is. 25 to the 1/2, what do we think it is? Well, 3 squared is 9, so what squared is 25? Let's guess that that's 5. Let's make sure that that's true. 25 to the 1/2 is 5. So it does say predict the following as a numerical value, which is what we did, but then it also says write them using a radical sign. A radical sign looks like this. And we have seen them before with square roots. Well, we had decided that the square root of 25 was 5. So 25 to the 1/2 as a rational exponent is the same as the square root of 25 in radical form. Okay, so 27 to the 1/3. Up here when we looked at 1/3, this was saying what times what times what gives us 27. Well, 3 times 3 is 9, times 3 is 27. So I'm guessing that 27 to the 1/3 is 3. Let's see if that's true. 27 to the 1/3. Yep, it's 3. So again, we have to use a radical sign. So when we write this, that 27 goes into the radical sign, but this is different than here because 5 times 5 gives us 25. That's a square root. This is called a cubed root. So that 3 has to go inside the radical sign to understand that this is a cubed root. So what we are looking for is what times what times what gives us 27? 3 does. What times what gives us 25? 5 does. That 2 is just unknown. Okay, we understand that that is a square root. Okay, so now we understand the relationship between rational exponents and radical forms. This is saying the square root of 25. This is saying the cube root of 27. Okay, now we have something a little bit different because here our numerators were 1. Here now we actually have a number there. So now we're supposed to try the following. First in our calculator, then using a radical sign. So let's go ahead and see what 25 to the 3/2 is. Not just 1/2, but the 3/2. 125. Okay, so let's figure out what that means. We know that 25 to the 1/2 is 5. So what did they do to 5 in order to get rid to 125? They took it to the power of 3 because I know 5 to the power of 3 is 125. So how did they do that? So to rewrite that, what they did was they took 25 to the 1/2 to the power of 3. And does that make sense? What is 1/2 times 3, our power to a power? It's 3/2. So that does make sense. So now we have to use a radical sign. Well, we know how to rewrite 25 to the 1/2. We're going to write that as the square root of 25. So what we did was we took the square root of 25 and we took that answer to the power of 3. So when we have a rational that has a number in the numerator, what it means is look at that denominator. That's what's in the radical sign. And then we're going to take it to the power of the numerator. Okay, so let's look at that on this next problem. 27 to the 2/3. Let's see if this works the same way. 27 to the 2/3. We end up with 9. So how did we get that? Let's look at this. Well, again, up here, we know 27 to the 1/3 equals 3. We also know 3 squared equals 9. So what we did was we took 27 to the 1/3 and then we took that value and squared it. Does that make sense? Power to a power 1/3 times 2 is 2/3. So with this piece right here, how are we going to write that in a radical sign? Again, this is how we wrote the cube root of 27. So this piece in the parentheses, we are writing as a cubed root of 27. Again, we have to have that 3 in there now, so we're realizing that we are saying what times what times what gives us that 27. Then we took that answer and we squared it. Okay, rational exponents, looking at two different ways. Okay, rational expressions, which would be this, transferring it down into radical form, which is this. So those are the two concepts that we're going to learn in this section. Go ahead and get out your notes and vocab for the section. Okay, objective of the section is to apply those rules of exponents, but now our exponents happen to be rational exponents. We know rational means that we're dealing with fractions. This first part explains what we went over in our introduction, understanding rational means fraction, understanding that if we take something to the 1/2 power, that's actually taking the square root of that. So what that's asking is what times what gives us 16? 4 does. Sometimes we don't get a very nice answer. What times what gives us 38? Please don't divide that by 2. It's what number times itself will give us that. Nothing really nice. So sometimes we won't be able to simplify. That is actually what we're going to do next section. So right now we're going to just focus on looking at expressions in radical form. Okay, radical forms deal with the radical signs. Or write each radical in exponential form. Exponential deals with exponents. Okay, so this first one is written in exponential form, which means we have to change it to radical form. So we know that we are going to have a square root of some sort. We had decided already that this means just the square root of 25. Okay, to the 1/2, we don't have to put that 2 in there because it's known. Looking at this one, this is in radical form. We have to write it in exponential form. So whatever is inside the radical is our base. We know since this is just a square root sign, this is 18 to the power of 1/2. Okay, C is exponential, which means we have to write it with the radical form. So right away, I know I'm dealing with the radical sign. This is kind of tricky. What is to the power of 1/2? Just the x. X is to the power of 1/2. We are multiplying 5 by that on the outside. Okay, now looking at this radical form, we know that this is going to be exponential. So the base is what is inside that radical, both 8 and p. We are taking both of those to the power of 1/2. So this is tricky. Look at the difference between D and C. Here, just Cx was taken to that power. Here, both of them are. And because of that, I had to use those parentheses to show, again, that 1/2 is affecting both of those. Okay, so good vocab in here. Understanding the difference between exponential form and radical form and being able to translate between the two of them. Okay, try it out on guided practice 1. Okay, A and B, pretty straightforward. C, I realize that both 7 and W are in the square root. I realize on D that just X is to the power of 1/2, so I did not put parentheses around there, and that way I understand that 1/2 is just affecting the X. Okay, we looked at a cubed root. We knew that that was the power of 3. Sometimes we have what's called the nth root, where we go above 3. We know what square roots are, we know what cube roots are, but look at this here. We're looking at a fourth root down here, okay, with what times what times what times what gives us 2. So we can put any number inside that radical, and whatever number that is, that's what we're asking. What times itself that amount of times is going to get, or will give us a nice number. Okay, they do give us a couple other things here about positives and principal roots. Some good vocab, but I really don't think that you're going to see it very often. A lot of times understanding the difference between those negatives, putting those negatives in parentheses. So we're supposed to simplify these nth roots, something that goes above a square root. This has a 3 in it. Let's get that calculator out real quick. Okay, looking at this calculator, notice that we do have a square root sign right here. Notice we don't have a third root sign anywhere in here. So what we have to do, and I'm going to put the, just a sec, let me see what number it is, 5. All right, I'm going to put the steps on how we would put this in our calculator. We would have to actually write 3 because we are saying what root it is. We are going to have to hit the math button. Then we hit the nth root button, which is 5. Then we type in 27. Okay, so what that's asking the calculator to do is find the cube root of 27. So let's go ahead and try that. We are asking for the cube root, math. That is an nth root, so we're going to hit 5 and then 27. Okay, notice it did have a cube root in there, but this is good practice on how to work that. So the cube root of 27 is 3. And we did know that because we worked on that on the introduction. So good practice for how we're going to put b into the calculator. Again, we are looking for the 5th root, so we're going to have to tell it 5. We were telling it to find that nth root of 32. 2. Okay. Another way that we could do this, since we understand that this actually means the same thing as 32 to the 1/5, we could put it in the calculator like that. Okay, knowing how to transition between radical and rational form. That did not work because I didn't do to the 1/5. So 32 to the 1/5, it's hard to talk and type at the same time, is 2. Okay, either way, you can use that nth root or you could write it as an exponential form and you should be good to go. Okay, so either way you want to do that, go ahead and try guided practice 2. Okay, I realize 64 to the 1/3 is the same thing as saying the cube root of 64. 10,000 to the 1/4 is the same thing as saying the fourth root of 10,000. Also, remember what we're looking for. We are looking for the number that multiplied by itself gives us 64. By itself 3 times. So 4 to the 3rd gives us 64. 10 to the 4th gives us 10,000. Okay, now we're going to work backwards. Again, looking at those nth roots, we are going to represent it by rational exponents, which we understand how to do. We understand the cube root of 8 is actually 8 to the 1/3. It's 1 over whatever our root is in there. Okay, so simplifying these, you could change it into radical form if you wanted to, but that's why we have these handy dandy calculators. We're going to put what is 125 to the 1/3 in there. What times itself 3 times is 125? 5 is. Okay, just make sure that you use those parentheses. Okay, what times itself 4 times is 1,296? Well, we will find out. 6 is. Okay, so these really aren't too bad as long as we understand what they mean. As long as we could quickly convert that over to radical form, we should be good to go. All right, try guided practice 3. Okay, pretty easy calculator work on those. Looking at the power of a power property, we, in our introduction, split up a rational exponent that had both the numerator and the denominator, and we realized this is what we did. We took our 25 to the 1/2, and then we took that to the power of 3. So they are just showing this algebraically with variables, showing it with our 8 as well. So if you needed an example to brush up on, there it is. So looking at example 4, it does just say to simplify. all right, which is what we're going to do in our calculators, but I am going to split this apart just to make sure we understand what this is one more time. We understand that this is 64 to the 1/3, and then we took that and we squared it. So how would we write that as a radical? The 64 to the 1/3 we would write as a cubed root of 64. Then we would take that answer and we would square it. So this and this are saying the exact same thing as actually this. We could put any of these into the calculator. I am actually going to put that first one into the calculator. So 64 to the 2/3, what is it? 16. Okay, so calculator, use it as long as you understand what we are doing. So on this one, we are going to take 36 to the 1/2, square root of 36, which is 6. And we're going to take 6 to the power of 3. And we're going to find out what that is. But again, I'm just going to plug it in like it is as its rational exponent. And we get 216. Okay? So we're not being lazy that we're using our calculator because it does just say simplify. So we're using our resources as long as we understand what we are finding. Okay, try guided practice 4. Last section deals with solving exponential equations. It says in an exponential equation, variables occur as exponents. The power property of equality and the other properties of exponents can be used to solve exponential equations. So when we look at these are pretty high level type of problems. So I will show you how to solve them, but also how to use a calculator to find the answer as well. Okay. If we have bases that are the same, we can go ahead and compare those exponents. So that's what they did here. Our bases of 5 are the same. So we don't even look at those 5s anymore. We realize that our exponent has to equal 3. The only problem is our bases down here aren't the same. So we have to figure out 6 times what power is going to give us 216. And this is where kids get kind of frustrated because if you don't know your exponential values, it's really hard to know. So we'll start with 6 squared. Is that it? No. 6 to the 3rd. Is that it? Yes, that actually is it. So we know that we could rewrite 216 as 6 to the 3rd. So what do we know x equals? We know x equals 3. Okay, to graph it, what we would do is we would write this, set it equal to 0. So first thing we do is set equation equal to 0. Okay, so that means I have to subtract that 216 over. So I'm going to put in my equation 6 to the x minus 216. Then I'm going to find the 0. Okay, so first step, this is what I'm going to put into my calculator. So if I go to that y equals, if you remember, here's our y equals, we're going to graph this. We are going to say 6 to the x, if you remember that's our exponent, or our variable, minus 216. Then we're going to graph it. Our solution is right there. Okay, that is 1, 2, 3. Because what we did was we set this equation equal to 0. So where x is 0, we know, or where y is 0, we know our answer is. So we know x is 3. Okay, a nice little way to use a calculator. And that's what we're going to do on this next one. Okay, we could figure out the basis on how to do this. Again, what we're looking for is this 25. We want it to have a base of 5. So 5 to what power is going to give us 25? 5 squared. So I'm going to write that as 5 squared, but I have to say to the x minus 2. I know that that equals 5 to what power? 1. So now that I have my bases the same, I'm totally okay. I'm going to go ahead and just look at those exponents and know that they have to be equal to each other. So I know that 2 times x minus 1 has to equal 1, which means I'm just going to do some distributing. I'm going to do some, whoops. Then I add and subtract. and I multiply and divide. So I know that x equals 3 over 2 or 1.5. Let's see if that works with graphing. Again, first thing, set this thing equal to 0. So I'm going to have 25 to the x minus 1, and I have to subtract a 5 from it and set that equal to 0. Okay, then I'm going to find when y is 0. Putting this into the calculator, you do have to, where am I at? 25 to the, I do have to put parentheses around my x minus 1. So the calculator understands that whole thing is an exponent. Then I'm going to subtract a 5. If I graph that, where is my 0? My 0 is at 1.5. So I was right. Okay, use either of those different concepts to go ahead and solve 5a and 5b. Okay, to reiterate how to solve these, again, in order to solve, our bases have to be the same. So we have to figure out how to convert 125 to be a base of 5. So 5 to what value gives us 125? 3 does. So here right away we understood that x equals 3. A little bit harder to see on this one. We have a base of 12 and a base of 144. So 12 to what value gives us 144? Well, 12 squared does. So now that our bases are the same, we don't care about them. We're focusing just on the exponents, knowing that they have to be equal. So solving this out, I get x equals -1/2. Checking that in the calculator, I went ahead and subtracted that 144 and set this equal to 0. So this is what I put in for my y. I put in 12 to the parentheses 2x plus 3 minus 144. And I visually looked at where my 0 was just to double check. My 0 is at -1/2. I must have done it right. Okay. All right, one more example with the same concept in mind. It does say that we're supposed to refer to the beginning of the lesson, and I didn't put that in there. I apologize, but I'll put it in there. The equation that they gave us is we were looking at the percent that dealt with absorption of sunblock. Okay, so the formula that they gave us is that the percent is 50 f to the power of 2/10. Okay, kind of a weird type of problem. But it says that we're supposed to find the SPF that absorbs 100% of the UVB rays. So this is our percent. Okay, so we know percent is 100. We're going to plug a 100 in there. 50 f to the 0.2. Okay, we're trying to solve for that f because, again, we're supposed to find that absorption. So looks like I can go ahead and divide by a 50 over here, and I end up with 2 equals f to the 0.2. Okay, this looks kind of weird. I don't know if we could be able to set this up and figure it out. So again, I'm going to go ahead and subtract that 2 from each side. And I have f to the 0.2 minus 2 equals 0. And we're going to go ahead and put this into our calculator and try to figure it out from there. So I'm going to clear out what I had. I'm not going to put an f in there, but a variable is the same. So I'm going to put x to the power of 0.2. And I'm going to subtract 2 from that. And again, I'm going to try to find the 0 value of that. Well, doesn't look like I quite have it. It must be outside my range. So this is my x value, which means I have to go to my window and change that x value. The max, let's make it maybe 40. We're not quite sure where it is. Okay, we can't still see that. It's really hard to see right there. So we're going to go ahead and try a second trace. And we're going to ask it to find that 0. Okay, left bound is to the left of our intersection. So I'm going to put this way down here because this is to the left of our intersection. Right bound, we're going to have to go above the intersection. Goodness, come on, calculator. So I'm going to move this to above the intersection. So look at that. It looks like I'm above the x-axis. And it'd be for sure over here. We don't do the whole guessing thing. Okay, so right there, if you can't see it, you do second trace 0, left bound, find a spot below the intersection, find the spot above the intersection so it knows where it's zooming in on, and it found it, 32. Okay, so sometimes, again, knowing how to use these calculators really does work. So what did we just find out? That F equals 32. That is the absorption strength that absorbs 100% of UV rays. Okay, so try as you might to go ahead and try this chemistry one, and then I will show you the steps on how to effectively answer it. Okay, kind of the same concepts. They give us the number A in the atom mass. They give us the radius. They tell us the radius. So if we solve down to a to the 1/3 equals 3, kind of tricky to see. So a to the 1/3 minus 3 equals 0. Okay, then we can go ahead and plug this into our calculator. I did, and this is what it gives me. Hard to see. So again, I'm going to go to that second trace and I'm going to ask it to find that 0 when y is 0. Left bound, I have to be to the left of my intersection. Then right bound, I have to be to the right of my intersection. When in doubt, go way the heck over there. Okay, there, I saw a bump. So I'm going to say yes, guess, no thank you, 27. Okay, so when we look at this, that actually does make sense, because this is saying what number to, what the cube root of what number gives us 27. Well, we were comfortable with that up here. We understood that that was 27. 27 to the 1/3 gives us that 3. So the more you know your exponential numerical values, the better off you're going to be. But that's a good way to use your calculator as well. Do I think you're going to see these type of problems? Probably not. But I would be comfortable with using your calculator nonetheless. Okay, go ahead and give the assignment for this section a try.